Hi, good morning, my dear students. I'm Daphne Cole. Welcome to my discussions. Today we'll discuss about the standard entropy change of solutions. The entropy change of dissociations refer to the heat that is released or absorbed during the dissolving process. Soluble compound will have a negative entropy change of dissociations. The more soluble the compound, the more negative its entropy change of dissociations. In other words, some ionic substances dissolve enthalpically, others dissolve exothermically. Now, let's go to the first part, the definitions of standard entropy change of dissociations.
When some compounds are put in water, there is a measurable entropy change. This is the entropy of solution. In these sections, we will consider only ionic compounds. However, how are we going to determine whether the ionic compound is soluble in water? So, we need to refer to the entropy of solution. Generally, an ionic compound is soluble if entropy of solution is negative value. An ionic solid is insoluble if its entropy of solution is positive value. Next, we will see what is the formula of entropy of solutions. Before we are going to use this formula to solve the problem, let's see what is happening when a solute dissolves in a solvent. It is involved bond breaking and bond formations. There are three key entropy changes involved when a substance dissolves. There are entropy change of solutions, lattice entropy change of hydrations. There are two steps here in dissolving an ionic compound. Now, let's look at the first step. In order for an ionic substance to dissolve in water, the ions in the lattice must be separated. This required energy to overcome the electrical attractions between the ions. The lattice energy must be supplied in order to break down a lattice and enable the ionic substance to dissolve in water. Now, imagine that these gaseous ions dissolve in water to form hydrated ions, which is the entropy of hydrations. Always bear in mind that the hydrations of any gaseous ion is an exothermic process since bonds are being formed. By using this energy diagram, we can determine the entropy change of solutions. From the energy diagram, we can determine that the formula of entropy of solutions is like this. Before we go to the questions, let's see what is the definitions of the standard entropy of hydrations. Always bear in mind that the hydrations entropy is the sum of the hydrations entropy of each ion. For the entropy of hydration, it is an exothermic step. Then, the higher the charge, the smaller the ions, the greater the entropy change of hydrations. Therefore, the strength of attractions between the ions and the water molecule is measured by entropy of hydrations. Now, let's look at the questions. Calculate the entropy change of solutions of sodium chloride by using the following informations. To answer these questions, we may draw the energy diagram like this. At first, we write down the solid sodium chloride, then it separated into its gaseous ions. This is the lattice energy of sodium chloride, which is -771 kJ per mole. Next, the gaseous ions are hydrated by water molecule to become hydrated ions. They are hydrated sodium ions and hydrated chloride ion. That's why we have hydration's energy of cation, which is -406, and hydration's energy of anion, which is -364. So, by using this entropy cycle, we can calculate the entropy change of solutions by following arrows of the cycle, which is clockwise is equal to anti-clockwise. Then we rearrange the equations. Lastly, the enthalpy change of solution is equal to +1 kJ per mole. As a conclusion, for soluble salt, the value of entropy change of solution is smaller than 0, while for the insoluble salt, the value of entropy change of solution is larger than 0. Always bear in mind that for soluble salt, the hydration's energy is larger than the lattice energy, or we can say that the hydration's energy is more exothermic than lattice energy. Then for insoluble salt, the hydration's energy is smaller than lattice energy, or we can say that the hydration's energy is less exothermic than the lattice energy. That's all for today's discussions. Thank you.